As you see, I'm today at the machine shop. This is our department's machine shop. We have several machines here in this room. I think about more than 10 lathe machines. We have some drilling machines, milling machines. We have little grinders. But as you know, today's topic is lathe machines, turning operations, and some hole making operations. I will briefly go through this machine, lathe machine, the components of it first, and then our friends will actually will show you some basic machining processes like turning, taper turning, drilling maybe on this one, knurling. They are all possible operations we can perform on this machine. So I can say that lathe machines are quite actually versatile. We can perform several machining operations on these lathe machines. So let's focus on the components. First of all, this machine is constructed on a bed. You can see that this large part here is called a bed. I may later show you the interior of it. And on this bed, we install other components and try to construct our lathe machine. And we can start from this side. This is called as headstock. And at the back of this headstock, I may later show you there's an electric motor here. We have pulleys, we have gears, we have a gearbox there. And with the help of them, we have to transfer the motion from the electric motor to the spindle here, okay? This is the main responsible, maybe the most important item of turning machine, since it is rotating, it's turning the workpieces. And on the headstock here, we have some, as you see, some kind of buttons, wheels. With the help of them, we can set the speed of this spindle. The maximum is 2000 RPM for our machine, but the biggest ones have maybe up to 20,000 RPM values, but this is a primitive version, so we have less, let's say, cutting speed or spindle speed, I'm sorry. And on this side, this was headstock. It's mainly responsible for the spindle, rotating the spindle. And then on this side, we have the tailstock. I can move this one. Actually, this is not rotating. Okay. Not rotating. Can you help? Now it's, as you see, moving on the ways. These are called as ways, and with the help of them, we can move this tailstock from one point to other point, and also if you are machining a long workpiece, we will see how it is machined. And in order to stabilize your longer workpiece, you may use some rest. There are two types of rest, follow rest and steady rest. As the name implies, steady rest is actually stationary. You put it here, and then it actually stabilizes your longer workpiece, and follow rest is moving along your workpiece. But they are all mounted on these ways. And at the tip of this tailstock, we have the tailstock quill. You will see some examples. And at the quill, we mount sometimes centers. And there are two types of centers, dead center and live center. Dead center means that it's not rotating. But as you see, this one is rotating. And this is called as live center. It will be rotating at the same speed, probably very close speeds with the workpiece, but the dead centers are not rotating. And then we move to this side. This is our carriage. And carriage is another very important component of the lathe machines. And on this carriage, we also have cross slide, okay? You may use both of them at the same time. You should be highly experienced, okay? Since this is manual, if you want to perform machine complicated shapes, you need to be quite experienced. And this is the whole assembly's carriage is moving in the x-axis, and then we have cross slide. And so this is moving into the machine. That's why it's called as cross slide. It's crossing actually the x-axis or the race. And then on top of this cross slide, we have the compound rest. With help of the compound rest, we can rotate this piece here. And with help of this rotation, we can easily orient our cutting tools in any angle, in any position. And on top of this compound rest, we have a tool post here. This is the tool post, and we mount our cutting tools onto the corners of this cutting tool post. And as you see, this is a square version. We can say that this is square turret, and we can have in maximum 4 different tools. But right now we have 2 of them installed. In a moment, I will show them maybe a close-up view. We have a knurling tool installed here. I'm not sure whether you can see these rollers. They have special patterns on them. And if you remember in the knurling operation, we are not removing material, but we are forming the workpiece. And at the end of this knurling operation, you will have high surface roughness on the workpiece, and it's highly useful if you want to increase the surface roughness of your workpiece. And then on this side, we have a single point cutting tool. I will show you in a close-up view in a moment. You can perform main turning operations or taper turning. These are the things you can do. And if you want to further do, for instance, drilling or boring operation, then what you need to do, you need to install your tools into tailstock. These are only possible, boring and drilling operations are only possible with the tailstock. You can move them in this axis and try to open holes. In drilling, for drilling operations, you may use special drills, but it's not a must. Even you have only a lathe machine, you can still perform drilling operations by, as I said, installing proper tools into this tailstock coil. And in general, we have, as you see, many wheels, hand wheels, and some arms. Arms are mostly used for fixing, and wheels are mostly used for moving the axis or moving some other items. Then I may focus on this. I'm sorry, guys. I will focus on the top here. Yes. You can see this is our spindle. This is rotating in maximum for this machine. It's 200 to 2000 RPM. And as you see, this is how we mount the workpiece. This is called as a chuck, and it has 3 jaws. That's why it's called as 3-jaw chuck. And it is self-centering by simply, I think, this one, right? Rotating the screw. You can fix your workpiece or remove it. It's not that complicated. And for longer workpieces, as I mentioned, you need to put your workpiece in between the centers. This is the other center you can use. And let me show you the cutting tools here. First of all, this is the knurling tool. As you see, it has special patterns on the surface, and with the help of it, we go into the workpiece. Since our workpiece is rotating, these are free to rotate, so once they are kind of locked to each other, we can have such a special pattern, the same pattern on the workpiece. And here we have a single point cutting tool. Yes, this one here. As you see, we have rake face, flank face all around, and this is, by the way, since chips are moving over here, this is the rake face, and the other face is the flank face. And for the other corners, we don't have any tools installed, but it's up to you. You can install different cutting tools. And this part holding the cutting tools is called as tool post. And the part here, which is rotating around this axis, is called as compound rest. And this part I'm moving is called as, let me show it like this. This is cross slide, okay? And the whole assembly is, as I said, carried. So these are things I can say. And maybe lastly, we have a kind of a chip pen here. So it's collecting the chips generated in the machining operation. And later, you may do recycling if you want. But these are the fundamental things. And I think I forgot to talk about these rods and screw. So this is the screw, as you see here. It is actually responsible for transferring the motion from the spindle or from our main electric motor to the carriage. And with the help of it, we can have a relative motion between the spindle and the carriage. And this is highly important if you are going to produce complicated shapes or if you're going to produce threads. And in addition to the screw, we have two more rods. These are called feed rod, and it's responsible for actually carrying this work, carrying our carriage, obviously, and it's used for moving it over this x-axis properly. And on also here on this side, as I said, these are the buttons or wheels for setting the speed of the spindle, and these are for the arrangement of the speed relation between the spindle and the carriage. I think these are all I can say. I mentioned all the components. You have questions, guys? Any questions do you have? Please don't type them in chat since I cannot access the chat. But if you have, please feel free to ask. Questions? No question? Okay. Then we may start some machining process. I think it's better we switch the view. Now this is our single point cutting tool, and you will be doing some main turning and maybe taper turning operations. Now he's performing end facing operation. He's only moving the cross slide over the workpiece. So the end face of our workpiece is machined and it has high quality. Now end facing is performed. Is going to do some basic turning operation. Now you see the process is all manual. We don't have any speed, but right now he set it to a constant speed, and you can see some continuous checks around. As you see, it's tangling around our workpiece. Our cutting tool is quite dangerous. Since we haven't set parameters properly, we have continuous chips. Now he's going to make conical tapering now. It will rotate our tool post a little bit and have a kind of a taper turning operation.
Hocam, pardon.
Yep.
Don't these continuous chips cause problem during the machining process?
Yep, obviously, since as you see, it may scratch your workpiece, it may do harm on your spindle, it may decrease the life of your cutting tool, as you know. So we have such problems with continuous chips, and we should actually find some ways to eliminate continuous chips. Now he's performing a taper turning operation. So with this operation, we will have a kind of a conical surface on the outer profile of our workpiece. Again, we have continuous chips, as you see. If you have questions, please unmute yourself and ask. I don't have access to chat right now. Now he's going to perform a knurling operation. Any questions during we are arranging the tools while we are arranging the tools? Yes.
Can we give some tolerances according? Can we make pieces according to some tolerance?
What do you mean?
For example,
you may have a look at knurling operation.
Okay.
I will answer your question in a moment. Right now we are doing forming operation. Now you can see the result. As you see, it has the same profile and the temperature is quite high. You can see gases. Now we have a high surface roughness value here, but probably the temperature of these rollers are a bit higher, so I'm not going to touch them. Now we may perform a drilling operation. He's going to do now first. Okay, he's going to do the drilling. And now, but before drilling, let's have a look at a longer workpiece. How we are actually machining longer workpieces. Now you will see that we are feeding the workpiece through the spindle, and we can do it at the back side. Let me show you. Since we have an opening through the spindle, you see that this is a quite longer workpiece. The end is here, and the other end of our workpiece is, you can see, yes, this is the other end. Now, after opening a hole at the space, it will be a kind of a centering operation. So for centering, let me show you, he is using a quite stiff tool. You can see it's a very small tool, but it's quite large, its diameter is quite high. And we are opening a little hole, not too much. It's for centering operation, since we want to use actually the tailstock. Now he's going to change that tool and put our live center there. This is our live center. Now we can handle a longer workpiece. In fixing the workpiece, now the tailstock or live center goes into that little hole. Now we can easily machine a longer workpiece. Since if you don't have that live center or if you don't have a connection on the tailstock, then probably we will have too much vibration and it will be quite difficult to machine. Now again, he will set it to a constant speed. Yes, now in constant speed. This time, as you see, we have discontinuous chips. Since can anyone tell me why we have discontinuous chips? We are using the same tool, same speed, but we have discontinuous chips instead of the continuous ones.
Hocam,
Since we have
difference
quite
of workpiece?
Sorry?
Difference of workpiece?
No, this is made of the same material, they are the same. But right now it's a bit changed. Right now we have continuous ones. But usually, mostly we have discontinuous ones. Since we have quite high frequency vibration here, since our workpiece is long and we are not using any rest underneath. So it's quite vibrating. And due to these, from time to time, we mostly have discontinuities, but if the vibration is not too much, then it may generate some continuous chips. But we know that for all the time we want to have discontinuous chips, and this is how we actually manufacture machine such longer workpieces. And another thing, since we are using a live center, it was rotating almost at the same speed with the workpiece. And probably the temperature of our cutting tool is quite high. And since we have some friction there, as you know, and this is all actually I can say for the machining of longer workpieces. But as I said, if you want to increase your accuracy, then you need to have a kind of a rest underneath so that you have less vibration and the accuracy, the machining accuracy will be much better. Now we may perform a drilling operation. We will be doing this drilling operation on the other turning machine here, but they are the same almost. Okay, first, I'm sorry, before the drilling operation, we will performing an threading. Let me do the arrangements. Yes. He's using a very special cutting tool right now for threading. The previous one was made of HSS, high-speed steel, but this one is made of carbide. We are using carbide cutting tool, and you can see the threads form, but we cannot do it in a single pass. We will be performing many operations. And from time to time, he's going to check the depth of these threads. This special tool, whether it is fine or not, he's going to check the depth, and then once the dimensions are good, can stop the threading. But now we need to have, I think, some more passes. And as you see, he's doing all these processes manually. Here we have continuous chips. We may switch to this one, drilling operation. And now we will be opening actually hole at this end face of our workpiece. And as we have done in the long workpiece, before drilling, we start with centering operation. You see, we use a larger diameter hole, and it's not too long, since we want to have high stiffness for centering operation. Now centering performed, is going to change the tool and then do the drilling. Again, probably this is made of high-speed steel. Now drilling is performed. As you see, we are not using a drill press or a special machine for drilling operation. We are using the lathe machine to open such holes. So I can say that lathe machines are quite versatile. You can do many operations by simply changing the tools or by using the tail stop. No, that's fine. Okay. I think this is all for turning operations, but if you have questions, I may answer. You have questions, guys, regarding the turning operations or the lathe machines?
Yeah,
Hocam,
yeah, you can.
Let's go one by one, please.
hocam, what are the functions of the screws above these cutting tools?
Functions of what? Excuse, I couldn't get it.
Hocam şu bijon gibi duranlar var ya.
Do you want these ones?
Yes.
This is just fixing the tool post to the compound rest. And this is for rotating, actually. If you make it, can you open it? Okay, now by simply rotating, you can rotate. Okay, it's just for fixing the tool and the other, actually the tool post can be fixed with that arm. And these are, again, for fixing it to the below mechanical items. They don't have special functions.
Okay, thank you.
You're welcome. Any other questions?
Yeah, I have one.
I have.
There are some buttons on this machine. You said that this is used for regulating the speed of the machine. Can you explain it more specifically? These buttons,
Yes.
1 to CBA.
Okay. Let me first show you the back side, since I have the same turning machine here. You can see that we have an electric motor here, right? And
Yes.
on the shaft of the motor, we have a pulley, and that pulley is actually transferring the motion to the spindle. Now he's going to open us for us. You see we have a pulley system and gearbox. You see you have many gears there, and they are used to set the speed of the spindle. And we stress this is not a fully automated version. This is one of the primitive lathe machines. We set the speed by the help of actually these buttons. So what we do, you can see there's a little description here, little table here. We have 3 options, 3, let's say, wheels, A, B, C here, 1, 2 here, and some color here. So for instance, if you want to set your RPM to 355, then what do? You need to set it to green first, or second, doesn't matter, and then set this button to 2 and the other one to B. So if you do it, then your cutting speed, your spindle speed will be 355 revolutions per minute. And I think we have another, let me show you another table for the leads. So you don't need to spend time calculations. There are already some standard leads by checking these tables and setting your speeds properly. you can have different leads opened on your surfaces. And for the lead, actually, these are the main wheels. You need to set them, but obviously we need to have a proper speed relation between the spindle and this carriage. And the motion is transferred by simply these screws, okay? These rods have no function on transferring the speed. It's only for actually keeping our carriage in place, and with the help of these rods, we can move it over. But the motion is transferred with this lead screw. Any other questions? Yes? Yes, please go ahead.
I just said thank you.
Oh, okay. Okay, you're welcome. Any other questions,
Hocam,
guys? Yes.
can you hear me?
Yes, I hear you.
Hocam, when he was threading the machining part, the working material, how was he aligning each pass with each other?
He has quite some marks here, and he has a kind of stop, and then once he rotates the wheel, it stops at the same point. So we can say that there's a mark, and he aligned the wheel according to that mark. Since obviously you are at a good point, this is not a fully automated system, and you need to be starting at the same points in the upcoming passes during the actually threading operation. You're right, and it's an important issue, but this is done with the help of some kind of marking or some special stops.
Okay, thank you.
You're welcome. Any questions? Any other questions regarding the components of the lathes?
Hocam,
Yes.
how often do we change the tools? Do we wait them for break, or we change them like after using 1 hour or something?
Not 1 hour, but you need to check actually the amount of wear on the cutting tool. If it's too much, we need to, if the application is critical for you, most of the companies in professional life, they check the amount of wear on their cutting tool from time to time, and then decide whether this tool is okay to do the machining. But if they are not happy with the amount of the wear, if the amount of wear is too much, yes, then they need to replace it. But in our machine shop, since we are not using these lathes all the time, we may be using them maybe for 6 months, maybe a year. So it depends actually on how, what type of materials you are using, what is the importance level of your surface quality. So they all affect the frequency of your tool change. Any other questions? And I think we also have a kind of a cutting fluid supply. So it's required, we can apply this cutting fluid, but in this examples, in these machining process, we didn't use them. But again, if the machining will take too much time, it's better you use cutting fluid, since after some time we know that the temperature of the cutting tool will be increased and we will have problems.
Hocam,
Any other questions? Yes?
in the knurling process, is the diameter of workpiece increasing, or is it same?
No, it's almost the same. We cannot, we need to do some check, but we are not removing material. We are shaping it, we are forming it, applying some pressure. It may be a little bit higher, but obviously it has some volleys and some peaks. We cannot easily talk about pure diameter, but in overall, if you consider the diameter of the peaks, they are a bit higher, since we are not removing material and we are shaping the material. So if you want to form some volleys, then this material should go upwards, obviously. And that's why it's a little bit larger.
Okay, hocam, thank you.
You're welcome.
Hocam,
Yes,
you said that there are 2 types of tailstock heads. Can you explain them again?
Dead center and live center.
Yes.
We mount them here. If it's a live center, it will be rotating at the same, almost at the same speed with the workpiece. But if it's a dead center, it's fixed. This one is not rotating. Workpiece is rotating. So assume that this is my dead center. I have this workpiece here. Workpiece will be rotating, but the dead center is not rotating. And the problem is that there will be probably high friction and even you may melt your workpiece. So that's why actually for most of the time we prefer to use that syntax. I'm sorry, live syntax.
Thank you.
Hocam, can you hear me?
You're welcome. Yep.
I wanted to ask if there is any limit to the diameter that we can use for the workpiece. Like, can we use any kind of workpiece, or is it supposed to have a limit?
No, it is, since we have an chuck here, this is actually the maximum diameter up to around here we can use. This is the maximum diameter we can use, since if you increase it, then we will be colliding with the bed and we will not be able to do the machining. And also other thing, you need to check the position of your tools and other things. So that's actually how we specify the lathe. This is a swing, it's called a swing, the maximum diameter we can machine. And another specification is the maximum length we can machine. It is actually the distance between the tailstock and distance between tailstock and the chuck here. And lastly, another specification is the hole size of our bed. So with 3 specifications, we can talk about a type of a lathe.